Chapter 1, Section 3, linear equation functions, which we've all been talking about already. But now we introduce the concept of slope and then applications of how they're really used. So what is a linear function? Yeah, a function that does not have any exponents or special operations. So a linear function looks like this. Where m represents the slope of the line, and b represents the y-intercept. There are four primary types of linear functions, the graphs of which we're going to talk about. There are four primary types of functions. What's the difference between these two? Which one's which? Right. Well, this is an increasing function. How do we know it's increasing? Yeah. Remember, math is a language. As we go from left to right, the graph goes higher. So it's increasing. The second one is a decreasing function. Same reasoning. As we go left to right, the graph goes down. We have a horizontal line. And we have a vertical line. Each one of these, the basic shape of them, I should say, are defined by this part of the equation. The y-intercept simply moves it up and down. That's all it does. So if it's an increasing function, how do we know it's increasing? The slope is positive. How do we know if it's decreasing? The slope is negative. It's less than 0. Now comes the problem. A horizontal line is when the slope is equal to 0. And we're gonna define why this is in a second. And a vertical line is when the slope is undefined. So, but just by looking at the equation, the y equals mx plus b, if the slope is positive, you know the graph's going to be going up. If it's negative, it's going to be a decreasing function. If there is no slope, then it's horizontal. And if the slope is undefined, it's vertical. Now, the easiest way to memorize all these is like this. It sounds ridiculous, but it works. It's a picture called slope face. Looks like a face, doesn't it? So if it's going up, then it's a positive graph. If it's going down, it's negative. If it's going up and down, it's what? It's undefined. So we put a U under there for undefined. And if it's horizontal, the slope is 0. So you don't have to memorize anything. Again, don't memorize anything. If you memorize something, you'll forget it. If you learn it or draw some sort of pictures or some mnemonics for it, then it's easier for you to recall it. So let's look at what slope talks about. What is a slope? How would you define a slope? Mathematically, you'll see a slope as a rate of change. So whenever you see rate of change or slope, it's the same thing. What do you mean by rate of change? It's the vertical change divided by the horizontal change. What's that?
I'm probably gonna learn this soon.
Well, yeah, glide slope. Have we seen this stuff before? Vertical and horizontal changes. Remember yesterday, day before, we had this graph. We found the distance between those points. We found the midpoint. Now we're going to find the slope. Where this was A, this was B, and that was C. How do we define A? What was the definition of A? How do we define the equation of A? What's that? Nope. I'm just looking for A. I'm sorry. That's you said no. It's not the Pythagorean theorem. A is just this part right here. Which one?
Oh.
So what was the formula we used? Very good. X2 minus X1, because it's horizontal. That's the distance of your horizontal movement from X2 minus X1. What's the vertical? Hey, what you said was correct, but it wasn't correct in this context. So looking at this, my vertical change was y2 minus y1, and my horizontal change was x2 minus x1. And the letter we use for slope is m. So it says our slope equation is m equals y2 minus y1 over x2 minus x1. That is our slope formula. And once we define x1, x2, y1, y2, it's a matter of plug and play. So what is x1? Yeah, the first x I get to is 1. What's y2? 5. y1 and y2. Right. Because these are the points. 1, 1, 5, 4. 0.1 and 0.2. So that's 0.1 is 1 as at 1, 1. 0.2 is at 5, 4. So I plug those in there. So my slope according to the equation is y2, which is 4 minus y1, and 5 minus 1. That is my slope. So far, so good. Let's look what this means graphically. Remember, this is the y values, the y changes on top, the x changes on the bottom. So this top number goes up and down, up if it's positive, down if it's negative. And the bottom number is always positive, always goes to the right. So from the first point of my graph, my slope says go up 3. So 1, 2, 3, and over 4. 1, 2, 3, 4 to my next point. So once you have the first point, you follow the slope to the second point. Graph that one. So do we have our first point? Where? Right, at the y-intercept. You always have to have a starting point, and you always start with the y-intercept at 1. Now, from that point, follow the slope. From that point, it says do what? Go down 3, 1, 2, 3, and to the right 2. Put a dot, connect the dots, and you're done. So far, so good. So that's graphing is super easy. Find me the slope between these 2 points. So since we're looking for the slope, always start off by putting down your equation. The more you write it, the easier it is to remember it. Label the x1, x2, y1, y2. So x1 is 3, y1 is 4, x2 is -2, 5. Now just plug and play. So y2 is 5 minus y1, -2 minus 3. They're both negative. So is that your slope? No. Negatives always go on top. The bottom number is always to the right, so it has to be positive. The top number is positive or negative. So the way you would write it down would be like that, -1/5.
Why is
Because when we do our graph, we always start from the y-intercept. And then from there, we follow the vertical change. Now, if we did it like this, we'd go up 1, that means we have to go back 5 to the left. But a lot of things that we're gonna get to next is applications, real world problems, the bottom number is always time. Can time ever go backwards? No. So that's why the bottom number is always positive. Because we have to go forward. And also, when we do calculations, 2/5 minus 3/5. Whenever you have a common denominator, it stays there. It's always positive. If there's any negative, it only belongs to the top numbers. So that's what you're looking at. That's a very good question. So far, so good. Now, let's look at when we talk about horizontal and vertical lines. We're going to look at these 2 examples. Let's put 4, 3. So to begin with, I want you to notice 2 things. In this first pair of points, what do we notice? The x values are the same. In the second one, the y values are the same. So here we have same x's, and here we have same y's. That's going to be important for us to look at this stuff later on in the very near future. So let's do the slope. It's y2 minus y1, x2 minus x1. So what is y2? -5. Minus y1, it's 4. x2 is 3. x1, also 3. -5, since they're both negative, the answer is going to be negative. Add the numbers. 5 plus 4 is 9. 3 minus 3 is 0. What is this going to equal? Undefined. Because the 0 is on the bottom. And the second one, y2 minus y1, x2 minus x1. Zero over -9 is 0. So if you have the same x's, it's automatically going to give you an undefined slope. If you have the same y's, the slope's going to be 0. Let's see what the graphs look like. We have 3, 4. And 3, -5. And the second one, we have 3, 4, 4, 3. And -5, 3. So you see how this works? If the x's are the same, the slope's going to be undefined, which means it's vertical. It's not a function. Functions cannot be explained like this. So if it's undefined, it's a vertical line. If the y values are the same, then it's a horizontal line. The slope is 0. So that's the first part. We also have another thing we go with this. Because it's a vertical line, no matter what y values you give me, x is always going to be what? In this example, x is always going to be 3. So this equation of the line is x equals 3. The equation of the line is x equals 3. Because if all the x's are the same, it doesn't matter what the y is, the equation is just x equals 3. What do you think this equation is going to be? This is going to be y equals 3. If the slope is 0, that means there's no x's. It's only where the crosses the y-axis. So far, so good. Yeah, the in small chunks, this stuff is easy. But think about it. Over the last hour and a half, we put a lot of these small chunks together. But I'm not gonna push you too much further. We're almost done. Here's an example of an application of this stuff. By law, because of handicap, the restrictions and everything, handicap ramps have to have a certain dimension. For every 1 foot of rise, it has to have 12 feet of length. For every 1 foot, it has to be 12 feet. Okay, that sounds awfully big, because how many staircases you know that are 12 feet wide before you go up? So we can break this down further. We can say that 12 inches is 1 foot. And this is 144. So what's the slope of this thing? We can make it much easier that if we know the slope, it's much easier to figure out the stuff. How do we figure out the slope? Remember, slope is always rise over run. Rise means vertical change. Run means horizontal change. So in our case, we have either 1/12 or 12/144, which means the same thing. As long as you use this ratio in a calculator, what is 1/12? Well, let's see. One divided by 12 is 0.08333333. What does that tell us? What percent is that? Yeah. So take this number, what we just have up here, times 100. We get 8.33%. So we could have done change it to percent, probably 8.3. We could increase it. That is what we're looking at here. As long as your ratio, whatever numbers you give me, it's gonna, as long as it's that ratio, that percent grade, then it's gonna be okay for wheelchairs. Anything greater than that is gonna be too dangerous, too hard for them. Anything less than that, you'll have a very long slant. Is that what stairwells are made on? When you go up the stairs, what is the rate of change on the staircase? A staircase is 1-to-1 pretty much. 6 inches up, 6 inches out, or 1 foot, 1 foot. That's how come staircases are pretty short and small. But if you see a handicap ramp, it's really drawn out because it's much more difficult to go up. So that's an example of where this stuff is used. All right. Let's go back to this equation. It's got a name. What do we call it? What's that? That's the form. The name, we call it, is an equation of a line. Typically, when you're asked to find an equation of a line, this is the form you'll give it in. You'll give it in that form. Is that the only form that we have? No. We have 3 forms to do. The first one is the slope intercept that we're introduced to. That's y equals mx plus b. The point slope form and the standard form. Where a has to be greater than 0. A, B, and C are numbers, but A has to be positive. If A is negative, you have to change all the signs. A has to be positive. Look at an example here. Oh, okay. Example 10. If I gave you this equation, find me the slope and the y-intercept. So what is a slope? Anybody? What? Right. No. No. You're overreading it. You're partly right, but then you went overboard. Is that what, I don't see a 1/4 anywhere there. Use the numbers that are given. Remember, the slope is whatever's in front of the x. The number and the sign, whatever's in front of the x is the slope. The y-intercept is whatever the constant is, including its sign. But there's a problem here. Is that the y-intercept? There's a negative there. The y-intercept is a point, isn't it? It's a location of a point. For this one, B is equal to this. If you're asked for the y-intercept, you have to give me the location of the y-intercept. Graph that one. Where do you start? Yeah, so I start at the y-intercept. 1, 2, 3, 4, 0, 4. Always start off at the y-intercept. Then from there we do what? Go down 2, 1, 2, and to the right 3, right. Then connect the dots and you're done. That's all there is to graphing lines. Any questions? Yeah, there's only 10 minutes left, so it's not enough to go on further. We'll do that on Monday. We'll finish this is the end of section 3. I was gonna do section 4 also today. We only have 6 in this section, so we'll do section 4 and maybe section 5 on Monday. And then we'll finish it up on Tuesday and start chapter 2. Which again, now this is what I say is the afternoon class. If we have 11 o'clock, we have to finish this one, do that. So we have to cram all this stuff